common ratio of a GP given as R. First term, which is the A, they have given me this as R squared minus 3R plus 2. And then sum to infinity is S. I have to show this. When I refer to my formula sheet, sum to infinity is this. So let's start. My A is R squared minus 3R plus 2 over 1 minus R. Now, looks like the upper part, I can write it in the factorized format. 1 minus R. So far, this step has been easy for me. When I look at the numerator, I have R minus 1 and this part is 1 minus R. They are almost the same. How can I make them look the same and try to cancel them off? So what I'm going to do, I'm going to factorize the negative out of the numerator here. So I will get negative R plus 1, which is exactly same like the bottom part. Let's sustain the R minus 2 from the upper part. Do remember to put a multiplication here, otherwise you will get confused because of the notation. I cut this and I end up with negative R minus 2, which is equals to 2 minus R. So the first part is quite simple. Now the next part is actually asking me to find set of possible values that S can take. When you look at the word set of possible values, you should recall that it should be written in terms of inequality. Your answer cannot be written in equality format. How do we solve this? Given to me that S is this, I have managed to prove that S is 2 minus R. What is the possible value? Now, anytime you are using this formula here, there is always a criteria which comes along. This formula can only be applied if the common ratio R is in between 1 and negative 1. I don't understand. What are you saying? That part over here. Look at this. So let's write. So the R is between 1 and negative 1. Only when the common ratio is between 1 and negative 1, then you can apply this particular formula. Now, if I want to find the possible values for this S, I have to ask myself, what is my S? It's 2 minus R. Then I want to compare with what I have written here. I have a R here, fine. And then it is being multiplied with the negative here. So I want to do the same. I multiply with the negative. I told you that if you multiply an inequality with a negative, then you have to change your inequality sign. So it's going to become like this now. So this becoming negative 1 and this becomes 1. So let's rewrite this in a way we are very familiar with. Okay. So I'm going to write R is between 1 and negative 1 now. Okay, so far it looks good, simple. Then I see the S also has a 2 here. After I minus the R, meaning R being multiplied with the minus, then I'm adding a 2. I'm adding a 2 in order to get the 2 minus R. So what I will do the same thing here. I'm going to add 2 to everything. I'm going to add 2 to this. I'm going to add 2 to this. I'm going to add 2 to this. Okay, let's see what happened. You see, looks like this one can be solved. And what is this? This is exactly my S. I just proved that my S is that. So S is in between 3 and 1.